I'm Rebecca Costa, and I have Luis Alvarez, the CEO of Alvarez Technology Group, on the line to talk to us about what's really behind all this surveillance data and other information that's being collected. Welcome, Luis.
How are you today, Rebecca?
I'm doing great. Hey, welcome back from your European vacation.
Well, thank you very much. As you know, I was there for the Rotary International Conference. I visited Spain and Lisbon, and I tell you, I thought going to Europe I'd get away from this whole National Security Agency spying scandal thing, but it followed me wherever I went. I mean, the European papers were just all over it. It was really amazing.
Yeah, it really is. It's a bigger global story than I think even people here realize. You know, there's been a lot of controversy surrounding surveillance just in general, not only private citizens and reporter phone records, but the government, surveillance on the Chinese and the Russians. And we had former Congressman Mary Bono on a week ago, who's really concerned about consumer surveillance by large companies. So I just wanted to ask you, what's the technology behind all of this spying and data collecting?
Well, you know, you bring up a good point. It is really a technological issue that we're talking about, because spy agencies like the NSA or the CIA, the FBI, and even, you know, foreign intelligence agencies in France and Russia and China, they've been collecting information on everybody for forever. I mean, it's what they do. The difference is that technology has enabled these organizations to really, you know, leap ahead when it comes to their ability to slice and dice information. We hear a lot about this concept called big data, and that's really what we're talking about here. The confluence of inexpensive storage technology, which means you can store tons and tons of information, and, you know, super hyper processing power that allows you to analyze that data in ways that you couldn't do it before. And now these agencies are able to use you know, vast amounts of computing power to look at data differently than they have in the past.
Right. You know, I tell people it's like, how fast can you connect the right dots when you have millions and millions and millions of dots? And suddenly now we've got processors that will do it so quickly. And the cheap storage has allowed us to just amass so much data. But even so, you know, speaking about IBM big data, in talking to IBM, they were saying that still 95% of data that's being created, from text to, you know, phone calls and whatever, is unstructured.
Right.
So what does unstructured data mean to the layman?
What that, you know, when we think of data, you kind of think of in terms of tables, columns, maybe like a spreadsheet where you have, you know, a certain number of rows and columns. But in reality, most of the data that we create is what you and I are doing right now. We're talking to each other, and that's unstructured data. It's almost impossible to be able to put that in neatly into rows and tables or columns or any sort of simple structure that makes it easy to evaluate. So the unstructured data is something that nobody's really found a way to look at right now. What we're talking about, especially when you look at the NSA scandal, is the structured data, the calls that somebody makes to another, you know, cell phone. So, you know, phone number one calling phone number two, and how long they were on that call, and what time of day it was, and where they might have been if it was a cell phone.
Right.
You know, that locational data. But what the actual conversation was about, you know, that is virtually impossible.
That takes a human being listening in to make some judgment calls on that.
Absolutely. And you know, that we focus on these spy agencies, but the reality is that it's, you know, everybody that has access to the resources to mine information is doing it. In particular, you look at the business community and how they're targeting consumers now in such finite ways, where if you've ever surfed the web, and you might have done a search on, you know, maybe you were looking for a new toaster, and from that point on, it seems everywhere you go, every website seems to be, you know, trying to compel you to buy a particular kind of toaster, and you're wondering to yourself, how do they know? Well, they're using this an analytical capability of big data to say, well, we know that this person is looking for this kind of information, let's make sure that they're presented with that kind of information. So hopefully one day they'll, push that button and buy that product.
Well, that's what I was saying to Mary Bono. I said, we're making this big deal about government surveillance of phone numbers, but the consumer surveillance is being done on all our activities, phone calls and actions on the internet, even to the point where there are now phones that track your eye movement and are now trying to do facial recognition to see, as you're looking at images, what kind of expression do you have. I mean, the amount of consumer surveillance is far and above and more invasive than what the government's doing.
Absolutely, because if nothing else, you have to at least have some modicum of trust that the government is doing the right thing, whereas when you think in terms of a business that's trying to sell you a product, hey, they're going to do whatever it takes to get you to buy that product. So the idea that big data and this analytical capability is just limited to spy agencies, that's just something we have to get over.
But there are some positives to big data, aren't there?
Well, absolutely. One of the things that companies like IBM, who you just mentioned, are doing, they're revolutionizing the way that we can use data to more quickly come to conclusions. So, for example, IBM is doing a project on the East Coast with healthcare professionals where they're able to put in symptoms and test results and all sorts of information regarding a patient, and then the computer will slice and dice it and come back and say, I think it might be these particular things. Let's run these additional tests to really nail it down. And, maybe a doctor can do that, maybe an internist can do that, but the computer's ability to look at not just that particular patient, but all of the other information related to all the diseases and all the symptoms that are out there, that makes it a very powerful tool for good and for helping more quickly diagnose problems and have better results with healthcare.
Now, I saw a demonstration of that. I saw a demonstration of their Watson computer in a hospital where an ER patient came in, and in normal, natural English, the person was giving all the information that they had on the patient, and then boom, 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 the probability that the patient had this problem, this problem, this problem in the percentage probability came out on the screen, really giving that person who had to handle the ER patient the advantage of years and years and years of medical information right there at their fingertips.
Yeah, and these computers aren't going to replace doctors or, nurse practitioners. What they're going to do is just make their jobs a lot easier because those folks aren't going to have to go back to the books and try to figure out, where are these strange symptoms and how are they all related. They can leverage computing technology just like we all do every day.
That's amazing. Well, that is all the time we have today. But as always, thanks for taking time to help us understand the technology behind the good and bad changes we're all experiencing. Thank you for being with us again.
It's my pleasure, Rebecca. This is Luis Alvarez, reminding everybody that when it comes to technology, forewarned is forearmed. Forewarned is forearmed. Forewarned is forearmed.